Hello again. I'm going to make this as quick as possible. What we're going to show you here is some programs that are going to be demoing RXB 2012. I want to continue. There we go. Alright, so I told you I was going to modify the, for 2012, I was going to modify the load program, of the loader I should say. So the loader has been modified, and it now creates a load program. And the load program has a feature in it, like we can catalog any drive after you hit that. When you go into your menu, if you hit any drive like 9, it'll catalog the drive. You could stop it, or you can go back. So if we want to catalog a drive like 1, you just hit 1 through 9, and it'll catalog the drive. Any key will stop the catalog, so you can pause it. Anyways, also C allows you to catalog a disk, like if we want to catalog like 5. There you go. So I said I was going to add that, and I did. So now we're going to go down the line here for the programs that I have here. We're going to start with boot tracking. What this does is it does boot tracking. Now let's list it out here. How this works is it doesn't use any assembly language. It peeks the address in this address right here, and then what it does is it calculates with CRU address. It finds the CRU address of the last device, because whenever you access a device, a DSR, this address will contain the last device that you talk to, the last CRU device that you talk to in Extended Basic. Works in Extended Basic or RXB. The problem is you can't turn the I/O from Extended Basic without assembly language, which means why even have a peek, because you're already going to have to do an assembly language anyway. With RXB, you don't need to. So the CRU address is this. We calculate it. Then we calculate the CPU address of the card's address for the names, because the last name that was used is going to be also on that list. There's 4 bytes there. Then what we do is that we use a command in RXB called call IO. We use 3, which turns on the CRU, 8 bits, and the CRU address, and it's 255 is what we want to turn on. So what that does is it turns on the card DSR, so we can look at the ROM on the card. Then what we do is we do a call moves to fetch that name, and it prints it out right here at the end down here. We print out, whoops, excuse me. It prints it out because it found it. And then what it does, the last thing it does is it turns off the card. And then this call moves right here, moves from that string. Now, this is interesting. $. If we save this program on 5 as a test program, disk 1. And save disk 5, load. And 5. Now, what it does is it fetches that 8C0, 80, excuse me, hexadecimal, it's 08CO. That address has the buffer for the last PAB that was used, peripheral access block, for the last device that was used. What's odd about this is sometimes it contains the name of the last program that you loaded, and sometimes it doesn't. I've never quite figured out why it's getting overwritten. The only thing I can think of is that maybe my utility itself is writing over the top of it. But sometimes it works and sometimes it doesn't. Anyways, you don't need to use it. You just need the device name is all you need. So if you want to track the path of the last device, you can at least get that. So that's boot tracking. Okay, next on the agenda is old disk 1 cat-all. This will not work in Classic. It'll, well, I guess it will, but it doesn't crash. I had to put this airline in right here. I had to put an airline in because Classic was crashing it. On a regular TI, I didn't care. It'll list out every device on the TI. It catalogs and just goes through all of them and gets till it gets to 128. It was crashing on Classic, but that was only because the disk drive on the Classic is different. it's to be expected. You have unlimited amount of space, so it's going to be a bit different. Anyways, then we have another program here. C loader, old disk 1 C loader. Oops. This right here is it loads C. If you have a C program you want to load, this takes the place of that. What it does is no assembly used. It does a call moves from RAM to RAM of this address right here. So it removes the addresses around in the RAM so that you can load C. So this would be a standard extended basic loader for C. Normally you'd have to use a assembly language program, the lower 8K, to pull this off. And FunnelWeb does that, and so I just copied it without having to use any assembly language. The disk manager was my attempt to write it was my attempt to write a disk manager in extended basic in RXB. And it does work, but it's got a lot of missing things in it. I was trying to make a disk manager using joystick. And it did function, but you know, like everything else in the world. I worked on it for almost 4 months. And it's a project that's almost done. You just need somebody to go through and then clean up the code. Probably the best thing you could do is just take out the joystick action and just make it a keyboard only, because it accesses keyboard and joysticks. So if you want to like do a disk, these are your keys. It works very much like everything else I've got written. You hit the enter the second time, it's done with what it's doing. It has a fire button for the joystick, enter for the execute. Then you flag the files for what you want to do. But this is my disk manager. It also works with a SCSI card or a hard drive. So if you want to catalog a hard drive or remove a directory, it does all those things. It has a menu system in it. So if you want to hit like Q for the fire, you can rotate through what it did. It's really badly written. I mean, like I was trying to do way too much with Extended Basic. I just wanted to show you that it's there. It's on the disk with 2012. Somebody wants to rewrite it, that would be fine with me. Disk 1, disk backup. This is a very small routine that is a sector copier. It won't work on Classic because, of course, Classic doesn't have sectors like you're used to. It's got a different format for it. I can read the sectors, but I can't write sectors on Classic, which is fine. It's for people that use the TI, that have a Graham card to use RXB. What this does is the sector by sector copy. It'll copy hard drives or disk drives. It doesn't matter. Anyways, let's go to the next one. Okay, now we're going to get down to the meat. What I started this project for was to do this. I've written a couple of utilities. One of them is PowerUp. Now we're going to go to the PowerUp first. Now, included in the original RXB was called a PowerUp. When you run this program on Classic, what you can do is go to Graham, and it does the PowerUp at 6,000. Hit OK. Hit Enter. Oh, click the keyboard. There it is. As you noticed, it went right back to Extended Basic. Let's do a buy. Interesting, huh? That's the PowerUp. It goes right back into Extended Basic. And you can use the period key to go back and forth between the two of them. RXB to Edit Assembler, back and forth with just the period key. And then you can load a file just by pressing the number. Now the PowerUp came with RXB originally, but a lot of people didn't like it because they like switching cartridges. Other people did. So you could turn the PowerUp off simply by running the no PowerUp. All this does is this pokes poke GROM the address for the PowerUp header. That's all it does. And then if you run the no PowerUp, the no PowerUp over here, no PowerUp does exactly the opposite. Okay, we're going to move into the next thing. I've already done loader, LineShow. Merge. This is LineShow. And what LineShow does is the program that I borrowed from somebody else I typed in, but I've modified it slightly. The original was all it was all in numbers. So it said minus 761 was the address, minus 781. Hard to read, so I changed it to hex so it's easier to read. Now you can have an output device where it'll actually output to the device what you're going to see on screen. So you can print up a file of what it is. If it's a huge program, you just turn it on and walk away. So we're going to say no. Now what it's going to show you is that it's going to ask for a keyboard press. Here's your line number table. It shows you where the address line number table is in memory and the end address. Shows you the address of the line right here. Line 1 is there. 2, 3, 4, 5, and that's the last. And then 8 is the last line for the program, the LineShow. Now this line is the first line on my no PowerUp, second line, third line, fourth line, fifth line, or whatever. And then it shows you total bytes, number of lines. What's interesting is if you use my call hex in RXB, we can go FF3F and then N. Get a hit on myself here. Okay, that would be minus 93. So the program used to put stuff like minus 93 right there. So if you went to a call peak minus 193 AB, this would print up. Now the lines are backwards because Extended Basic stores the opposite direction you would think into memory for the line numbers. So when you're typing a program in, everything's kind of backwards. It takes some getting used to. There's some information on how to do this, and it comes with, if you look up Barry Travers, some of his stuff in PowerUp, and some other stuff in MicroPin even explains about that. Let's move on here to something else. If you look at my listing here, I almost forgot about this. It's listed up here as unprotect. So what we can actually do is make this program unprotect this load program. It's a user file. What it does is it goes through the program. If you have a protected program, just go old with the old program, old with the program, and then what you do is you run this, you call user to this file, which is unprotect. It will load the program, and then what it'll do is it'll turn on the unprotect bits, turn all the protection bits off, so you can list out the program. If it doesn't list, then there's some other protection mode here. It uses 3 different methods for unprotecting the file. If those don't work, then you've got something that's really, they went out of their way to protect it. I have a program here called IV2548 only. Oops. What this does is it goes into Extended Basic. We set the option in gram for 8,000. Now here's what's interesting. Now I already did a demo of this where you can run my RXB, change the entire 8,000 GROM at 8,000, the whole 8K GROM, and it will do save and load internal variable 254 without a problem. Watch this. And this program test. There it is. Now it should be and it worked. It actually saved it. So this little program does work, but last night I was having problems. It may be the fact that I had to reboot my computer. Maybe that was the problem. So essentially, I think that's all the demo. That's all I wanted to show you guys. I wanted to make it very quick. The only other one we have here is the opposite of internal variable only. Is this one right here, which is program only. It's just the opposite. It turns off the bits, puts them back exactly the way they were. You don't have to use it though, because if you just reload RXB in Classic. But if you have a Graham device, you're going to have to use these right here. So that's the last demo. The next thing I'm going to do is release RXB 2012, guys. That'll be out shortly. Bye.